Hi everyone, welcome to Lecture 2. In this set of videos, we're going to talk about frequency distributions and normal and non-normal distributions. We're going to get into descriptive statistics and dispersion, and we're going to talk a little bit about probability. So if you're ready to go, let's go ahead and get started. Okay, in this first video, we're going to get into what's known as frequency distributions. So when we talk about frequency distributions, we first have to know what frequencies are. And as you can see from the slide, frequencies represent the rate or the occurrence or the count or how many of a particular measure exist for a characteristic in our data set. So if we were to look at the graph on the left of the slide here, let's say we had a group of 22 individuals and we were trying to classify or organize how many of those people had blue eyes, brown eyes, or other colored eyes. And what you can see is that if we were to go through the 22 individuals, person by person, and have them check what color eyes they had, we would be able to see and count how many people had blue eyes, how many people had brown eyes, and how many people had other colored eyes. In this case, it was 6, 12, and 4. And so what frequency values really represent is the actual number of people who have an absolute value of a particular characteristic in our data set. One of the beautiful things about statistics is that we can organize our data both in terms of a table and as a graphical representation, as in the case here with the histogram. So all that a histogram really is it's a type of bar graph that represents graphically in a way that people can understand them. So as you can see, we are using a bar graph structure with the x-axis representing the measure of interest and the y-axis representing the frequency of the occurrence. So if you look at the x-axis here, which is the horizontal axis, we have the different characteristic options that exist for eye color: blue, brown, and other. And on the y-axis, we have the frequency, or how often that blue, brown, or other colored eye represents itself. So histograms are a type of bar chart that helps us organize graphically our frequency distributions. The other thing that we think about when it comes to frequencies is on a relative perspective, we are trying to get a sense for what the ratio of something happening out of the total sample and representing that with a single value. So in the case of percentages, we're looking at the ratio of an occurrence, blue eyes, out of the total number of people in the sample, which is 22. So in this particular case, 6 divided by 22 gives us a percentage of about 27.3%. So 27.3% of the sample of 22 individuals has blue eyes. Similarly, 12 divided by 22 represents 54.5% of that sample, and 4 divided by 22 represents 18.2% of that 22-person sample. And so it provides us a way in terms of how we take these absolute count measures and we relativize them in a way that gives us a sense of what percentage of the total sample has that character trait. Okay, so percentages are all about relative measurements, whereas frequencies are more about absolute measurements. Very similar to what we were able to do with the frequency distribution tables and then converting them into a graphical representation of the histogram, we can do the same thing for relative measurements of percentages and represent them with a graphical representation known as a pie chart. So in this particular example, you can see that 18.2% of the 100% circle is represented by other colored eyes. Well, that 18.2% came from the other percentage that we calculated here. Similarly, the 27.3% that we calculated on the previous page is represented in the shade of blue, and the 54.5% is graphically represented on the pie chart as well. So we use pie charts to graphically represent data that is collected from relative percentages, and we use histograms to graphically represent absolute data that's collected from frequencies. Okay, so these concepts are really helpful because in this class and with the next assignment, you'll see that we're going to ask you to develop frequency distribution tables. We're going to ask you to develop histograms. We're going to ask you to calculate relative percentages, and we're going to ask you to make a graphical representation of pie charts. So really, when we think about frequency distributions, we can also do it in the context of grades. So everybody in this class is taking this course, and you'll all have a letter grade by the end of the term. And so we need to think about, what does this distribution look like when I have more than 3 categories, right? In the case of eye color, we only had 3 possible options. But in the case of grades, we have many possible options, from an A+ to an A to an A-, all the way down to a C, C-, and D+. And so there's many, many more counts, there's many, many more frequencies and possible options with which we can generate a frequency. And this is going to create something that we know as the normal distribution. So when we look at the normal distribution, this is what we call the bell-shaped curve. And the reason why we call it a bell-shaped curve is because this curve looks like a bell shape. If you look at this red line splitting the bell-shaped curve in half, you will notice that the area to the left of the curve is equal to the area to the right of the curve. And importantly, in the context of this class, when we're looking at frequency distributions, or how often an occurrence is happening, percentiles help us to provide an understanding of what the relative position of any one score is as compared to other scores in that larger distribution. So for example, in a perfectly normal distribution, the mean, the average score, the median, the middle score, and the mode, the score that occurs most often, are all going to equal 0. And so this X bar value is represented by 0, at which 50% of the scores fall above the 0 and 50% of the scores fall below the 0. We then have something that's known as standard deviations, which we'll get to later on in another video in this sequence. But if you were to look and go 1 standard deviation above the mean, you would see that 34% of scores out of the total percentage of all scores in the data set would have a value that falls within 1 standard deviation above the mean. Similarly, because scores can go above or below the mean, that means that 34% of the scores will likely fall below 1 standard deviation below the mean. So 68% of scores, on average, will fall between plus or minus, plus to the right, minus to the left, of 1 standard deviation above and below the mean. Building upon that, if we go to a second standard deviation, you can see that there is 13.5% of scores that fall above that first standard deviation, or 2 standard deviations above the mean, 1 standard deviation above the first standard deviation. And similarly, we have 13.5% of scores that fall 2 standard deviations below the mean. So 95% of scores fall within plus or minus 2 standard deviations above and below that mean value. And 99% of scores, therefore, fall within 3 standard deviations above and below the mean. So percentiles are really helpful because they give us an understanding of where any score in our data set from our sample, which was taken from the population, how that particular score compares to every other score about the mean. And that's really helpful. So I hope this video was helpful. In the next video, we're going to talk a little bit about normal and non-normal distributions. We'll see you there.